It's my pleasure today to introduce today's speakers, Doug, Stieve, and Jesse Torres. For those of you who may not know, Doug and Jesse are both from the New York office. Doug is a principal at WJE, and he's a licensed architect and a registered roof consultant, and has been with us since 1991. Jesse Torres is a senior associate. Jesse is also a registered roofing consultant and has been with WJE since 2007. Prior to that, he worked at NTH Consultants and Systems Roofing Analysis, Inc. And with that, I'll turn it over to you, Doug and Jesse.
All right, thank you, Rich. Thank you, Laurel. And good afternoon, everybody. First of all, we'll get through some last-minute housekeeping, discuss the learning objectives for AIA credits and in general. What we want to do is to be able to understand the principles of what an adhesive bond is. We'll talk a little bit about the various advantages and disadvantages of using roofing adhesives versus other attachment methods. We're going to talk a little bit about problems that we've seen, how to mitigate them, and how to diagnose adhesive failure mechanisms. One of the things I want to go over is this is really should be viewed as a roofing adhesives 101 course. We're not going to get into a lot of the chemistry. Neither Jesse or myself are a chemist, but we'll try to introduce enough chemistry and some other more technical things to understand the subject matter. But it's not a very detailed. It's still basically a basic course on roofing adhesives. We're going to talk a little bit about the history of glues and adhesive in the U.S. Roofing market, what types of adhesions are out there, some design considerations to be aware of when we're designing our waterproofing system with adhesives. We'll talk about different factors that affect our performance, discuss potential problems, both from what we've seen in the field and other cases, and Jesse's going to go through some best practices towards the end of the presentation. First, the history of glue. The Babylonians, about 4000 BC, used tree resins as glue. There's some history that indicates that the Italians have used tree resins about the same period. Natural pitch was first seen to be used in Europe about 5,000 years ago. Greeks and Romans, about the time of Christ, were using fish and animal to create natural glues. And there was a key development in the adhesives occurred in 1910 with the introduction of a thermoset plastic known as baked lead. Then in the 1920s, 30s, and 40s, we had a really great advance in adhesives with the two world wars. Wile E. Coyote in the 50s and 60s tried to stick the Roadrunner to no avail. And today we have the development of new adhesives for many markets, including the auto and aerospace markets, continues to grow. However, natural adhesives are still less expensive and are still more commonly used today. Did a little research into the historical use of adhesives in roofing, particularly in the United States market. And where we had first around the turn of the century, around the Civil War time period, we had composition roofing was first introduced in the Midwest. And the earliest we could find of adhesives in the roofing industry, other than the bitumen to stick the various felts together, was around 1920, where we found information that impregnated corkboard was used set in hot bitumen, mainly in ice warehouses and other buildings that needed to be kept cold for as long as possible. The roofing industry really went through a change in the early 1970s as a result of the oil embargo, and I'm not sure if people remember the odd even spacings and the the car lines we had to get gasoline, but the oil embargo really brought about the development of single-ply roofs and also the use of more insulation in our roofing systems. So we had a need to stick things together on our roofs. We had splice cements and bonding adhesives in the 1970s come about, EPDM seam tapes in the 1980s, also low-rise foam. It came about in the 1980s, and that's growing in popularity through today. Okay, what is adhesion? Well, there's different types of adhesion. First is specific adhesion, which is the molecular attraction between two contacting surfaces, either the molecules together or the electric combination of the two of them. We have mechanical adhesion occurs when an adhesive flows into the microstructure or micro cracks in the two things that are supposed to be mated together, the two surfaces that are mated together. The combination of the specific and mechanical gives us our overall effective adhesion. A little bit about adhesive joints and what they need, the forces they need to resist. On the left, we have an opening failure, which is what happens a lot of times on roofs when things lift apart. We need to be able to resist that lifting. We also have in-plane shear and out-of-plane shear, and that's when the two materials are going to want to slide across each other, whether they're in the plane, as shown in the center diagram, or in a sliding or a twisting motion, which would be out-of-plane shear. Okay, the types of adhesives for use in roofing. We have different adhesives that are used to adhere our membranes together. Bonding adhesives, whether they're solvent-based or water-based. We have bituminous emulsions. We have the historical hot bitumen, whether it's coal tar pitch or asphalt. And we have a lot of low-rise foams, either used to adhere the backside of a single-ply membrane or in a fleece-back membrane where we have a fabric that's attached to the backside of a single-ply, and the fleece-back is adhered into the low-rise foam as it's beating up, and that provides a much more tenacious bond than just the low-rise foam in the membrane itself. And there's also some applications where EPDM is used in a fleece-back membrane where it's adhered in hot asphalt. And we have insulation adhesives. And the materials, again, similar to a membrane adhesive, we have the low-rise foam, we have hot bitumen, mostly asphalt, sometimes coal tar pitch, and bituminous emulsions. The bituminous products that are either hot or cold emulsions are used. And the one unique advantage of the heated bitumen is that it's a thermoplastic adhesive, in that the material, when it's heated, it has less viscosity, and you're able to install it and get it to flow. And as it hardens or as it cools, it hardens, forming an adhesive. And on the picture on the left, we have the hot bitumen being used to set insulation boards. So that thermoplastic reaction takes place during installation. The roofing industry also uses post-installed or post-thermoplastic bituminous adhesives in the form of an asphalt shingle sealing strip, where the bitumen is heated in the field as the sun hits the roof and heats things up, and it seals the two asphalt shingles together. We have cold bituminous adhesives, which are basically an asphalt or a coal tar, which is the binder, and it's mixed together with a carrier, which is either a water or a solvent. And an emulsion basically is the mixture of two or more liquids that normally can't be combined together, similar to oil and vinegar in a salad. And the materials, again, we've got the asphalt, which is the binder, and it's dispersed in a carrier, which is either water or solvent. That water or solvent will flash off, and it'll leave the binder together to form the adhesive bond. Sometimes they add surfactants or other materials to keep the materials from mixing together or from coming apart in the can. Some of the cold bituminous adhesives, the advantages of using a product like this is obviously there's no flame, and easier to get a can of bituminous emulsion on a roof than it is a hot kettle. The disadvantages of this is that sometimes, and particularly with the water-based solvents, is that these materials take a long time to flash off or to properly cure. So you got to be careful about people walking over the materials before the material can flash off. We have bonding adhesives for single plies, and also is an emulsion, or not an emulsion. It's a very similar to an emulsion. Excuse me. Basically, it's a contact adhesive that will form a strong bond with high shear resistance. The contact adhesive is applied to both sides of the surfaces, and you got to allow it some time to dry. And then you push together, you mate the two sides together, and you put some pressure on it. You know, in a typical environment, it'll form a nice tight bond very quickly. Again, depending upon your working conditions. The different types of the bonding adhesives we have in terms of the carriers. We have the traditional solvent-based, which will flash off much more quicker. We have the water-based products, which are more VOC compliant. They're more environmentally friendly, and they don't have as strong odor as the solvent-based products. However, they take longer to cure, and there are some limitations to storage and use with the water-based adhesives. And we also now have low VOC, but still solvents that have a low VOC compliance that some of the manufacturers are starting to put out there. But I think the jury's still out and how well these things will perform in the long term. And we also have low-rise foam adhesives. Basically, they're dual-component polyurethanes. There's a part A and a part B, which is the resin, that are mixed together, usually a 1-to-1 ratio. And once they're mixed together and hit the air, they will form a chemical cure as they foam up, and Jesse's going to talk a lot about that within 4 to 8 minutes, but that could vary depending upon temperature and humidity conditions. We have different ways of dispersing the low-rise foams. In the center picture, a gun-grade cartridge-type application device is used, and very similar to installing sealant, or like a Hilti type of anchor. The materials are compressed into a long tube. They're mixed together in the tube. Once they hit the air, they start foaming up. Lower right-hand side, we have a canister device to store the materials and deliver the materials, very similar to a propane cylinder that you might find on your barbecue. We also have full coverage low-rise foams where the materials are actually mixed and delivered to a nozzle in different tubes. These tubes are usually heated to get the material to flow better, and you can put down a lot of adhesive in a short period of time. However, the equipment's very costly, and the folks that do this type of application really need to know what they're doing so that they get the proper coverage, the proper mix, and that they don't wind up clogging up the machinery. We've seen on the East Coast just some specialty subcontractors who all they do is put down the spray foam adhesive, and they do a very good job, but they just go from job site to job site, being a subcontractor to a roofing contractor. On the right-hand side, we have a little trolley device which supports and transports the canisters. The different foam spacings can be adjusted by that little red unistrut device we see, and the bead patterns, or the spacing of the beads, can be adjusted to resist different wind loads that we might find in corners and perimeters, as opposed to the field of the membrane. And we also see some adhesives used in the steep slope market, foam application, particularly in southern Florida, where we have some very high wind loads to resist. Or in this case, is being used to spot adhere the clay tile to the underlayment. And we're also seeing some sealants used as adhesives to basically seal or adhere the leading edge of the clay tile. However, intuitively, that seems to defeat the purpose of allowing water to be able to flow from one tile to the next. It seems like it may trap water, making that underlayment integrity paramount to the success of the roof. In EPDMs, we have the old-fashioned on the left, the splice adhesives, again, which is a contact adhesive, where the gentleman's putting the adhesive down on the one end, the other end gets adhered also. They would they would install some lap sealant in the seam to prevent water from transversing from one seam to the other, or through the seam from one sheet to the other. On the right-hand side, we have a newer type of butyl tape. It's a double-sided tape that's laid down and compressed, and usually performs better and creates a much stronger bond than the splice adhesive contact cements that we used before. Okay, some different failure modes that we need to be aware of when we're designing with adhesives are cohesive fracture in the middle towards the left and the bottom, similar to a sealant failure where the material itself, in this case the glue or the adhesive itself, fails within the body of itself. Upper right-hand side, we have an adhesive fracture where the adhesive or the glue, so to speak, will come off of the adherent, which is the material that's being adhered. We have a mixed fracture where the fracture will jump from one side to the other. And we have a failure to adherent where the stresses may be such that we have a breakage within either the adhered material or the glue adhesive itself. Now we also have reversion, which is something we're starting to see a little more of in water-based products, particularly the ones that are based on vinyl acetates, which came out of the flooring industry, where we're seeing that if they get re-wetted, they can actually revert back to their plastic state. And just some examples from the field. On the right-hand side, we have a cohesive failure of the sealing strip of the asphalt shingles, where the material got soft and actually lost bond within itself. And we have a picture of reversion on the right-hand side, and that'll look like a very tacky substance that you can actually take your fingers and push and create a little shear stress, whether it's in plane or out of plane. And it basically just has a feel and look to it that the material never adhered, where in fact it did adhere and is just re-wetting or reverting as it gets moist again. All right, what are some of these design considerations? Now we know a little bit about adhesives and how they work and how we're supposed to design for them. Let's look at them on a particular roof and whether we want to have an adhered roof. We've got a lot of odors during construction that we need to deal with. The solvent-based adhesives will have a strong odor to them. They can be flammable. They certainly can be noticeable. And are we working in an occupied building or in an area where we have people nearby? Do we have hot work restrictions? Are we able to get a kettle or a torch to melt bitumen up on the roof deck, or are we not able to do so? The geometry of the work area. Do we have low pit roofs, or do we have areas where where the fumes can accumulate and cause either a flammability problem or a problem with noxious vapors? Do we have access to the roof area? Can we get our materials up onto the roof? Can we get that kettle up onto the roof, or we can't, or are we just limited to bringing buckets up? And obviously the wind lift up requirements of a particular roof we need to be mindful of, and they'll come into consideration. And actually some of the adhered roofs can give us very, very high wind uplift requirements, provided we put down the roofing materials and the adhesives properly. All right, well that will lend us traditionally down the path to, well, do we want to use adhesives or mechanical fasteners, particularly as we're looking for attachment of the insulation boards to our roof deck. And some of the advantages of using an adhesive is that it's going to distribute, or they will distribute the stress more evenly across the joints. So you're not relying on spot fasteners. You're distributing that load a little more evenly. Can be cost effective. It'll be a little cheaper usually to put the adhesives down. You're going to have less impact to the roof deck, particularly on an occupied building, and be less noise, less vibrations. Less disruptive, and you're going to have less impact to the roof deck. For instance, if you need a whole bunch of fasteners and you have a gypsum deck or a steel deck, you won't be structurally impacting the deck with all the fastening and all the holes you're putting in that deck. Some of the disadvantages of using an adhesive rather than a mechanical fastener are the temperature stability. We need to have more stable and warmer temperatures. Moisture stability, we need to have not so much moisture in the air, and Jesse's going to get into these a little more towards the end of the presentation here. You're going to need a larger surface area for the bond, for the adhesives, and it's going to require a much cleaner working environment, particularly at the bond area, so that we're not putting our adhesive down to old roofing materials or to dust and debris, whereas a mechanical fastener application, we have a lot more liberties in terms of that, that one constraint. What are some other options to avoid if we absolutely don't want to deal with adhesives? Particularly if we're working in a single-ply roof, we can use a ballasted or an IRMA assembly, or we can go with a mechanically fastened roof. Now I'm going to turn the presentation over to Jesse Torres.
Thanks, Doug. I want to get into some of the installation factors that affect performance. What are some of these factors? Weather is an important factor to consider when using adhesives, whether it's the temperature, cold, hot days, humid days, the time of day when the adhesive is used. Moisture comes in various forms, whether it's precipitation, dew, condensation, as well as moisture in existing substrates. The effects of ambient conditions. Why does this have an effect on adhesives? For some two-component adhesives, the rise and spread from a liquid state to a foam state actually forms the adhesive. This foaming action develops a cell structure which can increase the contact area of the adhesive between the board and the substrate. So if the ambient conditions affect this foaming action, the adhesive bond between the two materials can be affected. For example, if we have the materials that are placed together before the cell structure of the adhesive is formed, the adhesive material may not function as intended. Or if the adhesive sets prematurely or more rapidly than anticipated, the materials will not be bonded. The tack time for the various adhesives, whether it's a hot day or cold day, is going to vary depending on the ambient conditions. The bonding adhesives must be tacky prior to bonding the two substrates together. They should be able to resist the shear prior to joining the surfaces. For some solvent-based adhesives, after the application of the adhesives to the two substrates being bonded, the solvents in the adhesive needs to flash off or evaporate prior to mating the two materials. This flash-off period would vary greatly with the temperatures. Hot days, it typically flashes off relatively quick within the first few minutes, whereas the colder days, that flash-off period is actually a little bit longer. The time of day will also have an effect on the adhesives. The moisture will act as a bond. Moistures on the substrates, depending on the time of day, will also have an effect on the adhesives. The moisture will act as a bond breaker between the two materials. This particular picture is of a morning time installation where the contractor was installing adhesive on the deck, and subsequently the deck had a small amount of moisture that was not visible to the eye or touch. The insulation was installed. The insulation subsequently had a dew on there, and after the first few days of warm weather and the sun would heat up the membrane, we noticed that the insulation was cupping. There was trapped moisture, in essence, that was not anticipated during the installation. So moisture on substrates has an effect on the adhesive bond of materials. Another factor that will affect adhesives are the substrate conditions to which you're adhering to. If it's directly to the deck, you should consider the profile of the deck, whether there's moisture content within the concrete substrate, or flashing materials if you're leaving existing substrates in place. You also want to make sure that the substrates are dust-free. Any surface contaminants could definitely affect the bond between the substrate and the material you're trying to adhere. You also want to look at the profile of the substrate that you're adhering, whether or not the materials are flat that you're adhering to, compatibility of the adhesive and the existing materials, adhesion of the existing components to substrates, and again, the dirt and surface contaminants, whether or not the existing substrate that you're trying to adhere to has any kind of contaminants that will adversely affect the adhesive that's being installed. The size of insulation boards also has an effect. Sometimes the performance will be affected because the size of the board is relatively large in relation to the unevenness of deck substrates. If you're trying to adhere a 4x8 board to a concrete deck, let's say, concrete decks are not typically as level as we would like them to be, and what we find is contractors slicing the facer of the insulation board so that they contour to the deck's surface. One of the ideal conditions is to use a smaller board that has a smaller surface area that you're trying to bond. This is usually the better scenario of the two, where you can use the adhesive, place the 4x4 board down, and weigh it down, where the smaller board has a smaller area to contour to the deck surface that you're adhering to. Now we want to get into some of the potential problems that we can have with adhesives. Some of the things to look for with adhesives, the various types of adhesives that we have, whether it's the cold adhesives, solvent or water-based, moisture cured, the hot bitumen, low-rise foam adhesives. Any types of these adhesive have factors that will affect the performance. So knowing the types of adhesive that are used on your project are very important to know prior to using them. This photograph is a typical cross-section, let's say, of a mixture ratio of the solvent adhesive for a single-ply membrane. 90% of the material is the solvent or the carrier, and the 10%, which is the bright yellow color, is the adhesive. The solvent acts as a carrier to deliver the binder product, and during this process, when the material is installed, this solvent is what flashes off or evaporates and leaves behind the adhesive product, which forms the bond between the two products you're making. So proper mixing of these types of adhesive is vital to ensure the proper adhesion of the materials being bonded. And as you can see from these photos, if you just were to pour a can into another can without proper mixing, you can see that you're pouring all the solvent out, and the adhesive or the actual product is at the lower end of the can. Storage and shelf life is also an important factor to consider and will vary between manufacturers. This first label says that the product can be stored for up to 12 months, and if the temperature in which it's being stored is between 60 and 80 degrees. So it's very specific with regards to the temperature range, whereas the other label just says that the low temperature has no adverse effects on this adhesive. But should it be stored at a low temperature, they want you to bring it up to a 72 degrees for several days after exposure. The other prior one says 3 to 5 days. So what's important here is that each manufacturer is different, so you must read the labels and verify dates of the products are clearly visible. So what may end up happening is if an adhesive is stored in a non-ideal condition, the materials themselves will become like a gel, become ineffective, will not be able to be mixed properly, so it would end up being wasted material. Cold adhesives, the set time prior to mating the two materials is going to vary depending on the types of adhesives you're using. On the left, you have a cold applied modified asphalt adhesive or emulsion that will tend to have a longer time to flash off or bond to the substrates. These typically have a temperature and consideration that you should definitely make yourself aware. And like we talked about earlier about the solvent or water base, these must pass the Tack test. Now, the Tack test is typically when the solvent is allowed to flash off until the adhesive does not string or transfer to a dry touch. This is usually recommended to be continually monitored throughout the course of using the adhesive, whether it's any time of the day. Distance away from the main kettle when using hot bitumen should also be considered. The further away from the kettle, the cooler the asphalt will be at the point of application. The bitumen must be at the appropriate aqueous viscous temperature or EVT range at the mop cart or mechanical spreader just prior to application. The gentleman on the left is using the cart, whereas the guy on the left or on the right is using the mechanical spreader. So if the kettle was, say, in the parking lot 200 feet away, you want to make sure that where this gentleman is applying the hot asphalt, that it's within the proper range of temperature during the application. And as you can tell, on colder days, this hot bitumen will cool a lot faster. Other installation factors that affect performance are proper coverage rates. Depending on the dispensing methods for the materials that you're installing, you want to make sure that you get the proper rates of coverage to resist the uplift performance of the roof assembly. You want to ask yourself, is the spacing adequate for the proper adhesion to withstand the designs or any kind of adhesive-related failures? The picture on the left, the squiggly line there, does not appear to have any kind of definitive distance between each bead. The one on the right may be somewhat of a 4 to 6 inch spacing with a few extra lines in there for good measure. Proper contact between the two materials that are being adhered will also affect performance. As I stated earlier, the smaller boards are more ideal in adhesive applications. You want to make sure that the insulation layers are weighed down until the adhesive has time to cure. This particular contractor has used concrete blocks to hold down the 4 corners of the cover board. The guys on the right are rolling the fleeceback membrane into an adhesive. Once this gentleman kicks the roll into the adhesive, the center gentleman will weigh down or brush or use a heavy roller to go over top of the membrane to make sure that the adhesive is in full contact with the fleeceback membrane. And just to piggyback on the previous slides, you want to make sure that the materials are not disfigured prior to installing them. This particular picture shows an insulation board that was possibly wetted at one time and has cupped. Try getting this piece of insulation to lay flat. Is definitely going to be a chore. We would recommend not using this type of material in any kind of assembly. Now we want to get into some of the problems associated with the newer foam installations. The low-rise foam, whether it's a bead or a full coverage, has potential problems associated with each kind of installation and dispensing methods. You can have off ratio of the Part A and Part B components depending on the dispensing mechanisms. The gentleman on the left has a spray nozzle that probably has a some kind of temperature range where it allows the A and B components to mix properly and dispense out the gun tip. The picture on the right shows the adhesive installation in a fairly large area where the contractor may have gotten ahead of himself. This type of over-installation may allow the adhesive to cure prior to bonding the two materials together. You also want to make sure that you get the proper embedment. As I stated earlier in the presentation, whether it's a low-rise foam with the rows or a continuous application, the dispensing method will vary. So the method to bond the two materials will also vary. You want to make sure that both materials that you're bonding are installed in the manner that the manufacturer recommends. Now I want to get into some of the example problems that we've seen over the years. We've seen some adhesives where the solvent has flashed through the cap sheet. Now, the components of the adhesive were the cause of the problem, not necessarily the contractor or the installation methods. It was the manufacturer's processing of the product that actually caused the failures. So that should be one of the items to consider, is that the manufacturer could be the root of the cause. We've also seen solvent flash through membranes where it's caused the delamination of any kind of liquid flashings that were installed on the cap sheets. We've seen flashing membrane not fully bonded to the substrates. We also seen the insulation layers not bonded to the deck because of moisture in the concrete, whether the moisture was there prior to installing the adhesives or whether it was just the moisture drive from below. And speaking of moisture, we've also seen the reversion of the water-based adhesives, similar to what Doug touched on earlier. Some of the problems that we've seen with the hot asphalt, the distance away from the main kettle may have been a cause for some of the failures that we've seen. The asphalt cools, where you see the picture on the left, the light gray colored dark areas show where the adhesive bond was to the insulation, and on the right you see a close-up of the darker areas, or where you see the visible sheen of the asphalt where it was allowed to cool and was not mated properly to the insulation. We've also seen installations where the solvent was gooped on the substrate and then covered over with the membrane. This excessive solvent that was not allowed to flash off will stay trapped below the membrane and cause blisters. We've also seen installations where the adhesive dried prior to mating the two substrates. This particular project, you can see that the adhesive is there. However, there's no mechanical bond between or molecular bond between the two substrates. You want to limit the sources of moisture. In one of the earlier slides, we talked about having the adhesive failures due to moisture in the deck or substrates. There are food and paper processing structures that generate moisture that drives through the deck. Notoriums, cold storage facilities, those types of structures and uses of buildings generate interior moisture that you want to limit any kind of adhesive or the moisture from getting to the adhesives. Another source of moisture is, of course, precipitation, whether it's the rain, snow, spills, etc., anything from the exterior. You also have the construction-generated moisture from gas heaters, machineries, etc. The concrete deck may be dry when the contractor is installing the materials and they want to close the roof so that they can continue construction on the interior. However, if it's in the winter months, all the heaters that are generating heat for the workers, all that moisture is going up, and it usually ends up on the underside of the deck. And depending on the amount of heaters that they're using, it could definitely cause failures in your roof system. So if some of these projects were using the water-based materials for the adhesives, you can see the reversion of the adhesive in the single-ply membrane adhesive. As Doug stated, the reversion of the materials actually gets to be like a gooey substance, kind of gets back to the form in which it was originally installed. Now we want to talk about some of the best practices that we've come across, that we've been trying to implement over the years due to some of the failures that we've seen. You want to specify the correct board size. I listed 4x4 insulation boards or cover boards. The larger 4x8 boards tend to be a little bit more cumbersome and don't necessarily conform as well as the smaller boards do. You want to make sure that the liquid materials are properly mixed. As I showed you in the earlier slides, 90% of the can may be a solvent or water-based carrier for the adhesives. So proper mixing is vital to actually having the adhesive bond the two materials. You want to require the boards to be walked in or weighed down, making sure that the two substrates that you're adhering are properly held together until the adhesive is cured is important. You want to check the local jurisdiction to determine if VOC restrictions exist. I know this is a big ticket in California and is gaining a lot of popularity in the Northeast as well, which is why some of the water-based adhesives are gaining popularity, is because of the VOC restrictions. You also want to limit the moisture ingress. The open gaps in construction allow the air infiltration, which in essence, carry the moisture into the roof assembly. Porous construction is a typical thing we see, during our day-to-day lives. And all these avenues for air infiltration to get into our roof assembly will tend to drive the moisture level in the overall assembly higher, and thus possibly affecting any kind of adhesive bond that we have between two materials. You also want to make sure that the proper transport and storage of any kind of adhesive materials is being followed. The manufacturer's labels should be read carefully. You also want to verify proper tack time between the two mating surfaces. Follow the manufacturer's instructions. You want to prevent the slippage of flashings. Again, when you're installing the adhesives, you want to make sure that the two mating surfaces are held together long enough so that the adhesive can cure and allow the adhesive product to do its job. And again, follow the manufacturer's instructions. This particular slide just shows that manufacturers have various charts, coverage rates, things of that nature to allow the contractor a couple of tools to follow during the installation of the materials. So in summary, we talked about principles of the adhesive bond, some of the advantages and disadvantages of using the roofing adhesives. We've also talked about some of the problems that we've seen with the adhesives, how to mitigate these problems. We've seen the diagnosing of adhesive failure, some of these mechanisms, as well as we've discussed some of our best practices.